Write an equation for a rational function with the given characteristics. Vertical asymptotes at x equals -5 and x equals -4, x-intercepts at -2, 0 and 4, 0, y-intercept at 0, 4. Okay, so to make all of this happen, what we need to do is think about how these different aspects occur in a rational function. So let's start with vertical asymptotes. So vertical asymptotes, what we should know is that these are the locations where the denominator is equal to 0. So I need to change these uh, values into factors. So changing them into factors would look like x plus 5 and x plus 4. And then those are going to be placed into the denominator of this rational function. So to start off, I have f of x equals something with a denominator of x plus 5 times x plus 4. And that's simple. That gets me the vertical asymptotes in the right location. Now, next up, I have some x-intercepts. X-intercepts are locations where the numerator happens to be equal to 0. So I need to take these x values, which are x equals -2 and x equals 4, and likewise change those into factors for my numerator. So this would be x plus 2 and x minus 4. So x plus 2 and x minus 4. Now the y-intercept at 0, 4. Now it is true the y-intercept does occur at the ratio of constant terms. But the problem is I don't have this in expanded form, which means I can't just come up with the constant terms as is. I'd have to factor these out to get them. And if I start changing the constants, then it could potentially make a problem with where the locations of zeros are. So in this situation, the easiest thing to do is just put in a constant multiplier of a. And using this coordinate pair, solve for it, because this coordinate pair is an xy value, and I can plug that xy value into the function that I have so far. Just remembering that f of x is, of course, equal to y. So what this is going to look like, when I plug in, I will have the y value is 4, so 4 equals a times, I have an x value of 0, so this is just going to be 0 plus 2, which is 2, 0 minus 4. And then 0 plus 5, so that's 5. 0 plus 4 is 4. All right, so these will actually cancel out to -1. I could multiply both sides by 5, so that would be 20 equals -2a, because I have a -1 times 2 and then a. Then just divide through by -2, and that tells me that that value a has to be -10. So the function that fits here is going to be -10 times x plus 2 times x minus 4 all over x plus 5 times x plus 4. And there's no need to multiply that out. You can leave that in factored form.